Okay, we have AAHL. This is time zone 1, paper 3. Alright, I do have a lot of requests on the HL November paper, so that would be next on my list. But I believe going through paper 3 would also be beneficial. After all, there isn't too many paper 3 like this before in IB. Alright, so let's go through this, well, rather quickly, I guess. Okay, so you're supposed to do all of them. You have no choice. You cannot, like, choose one of them to do. The question asks you to explore the behavior of a cubic in this form. So first we have D being 2, and then what? Oh, C is -1 and 0 in here. On separate axis, sketch the graph of y equal fx showing the y value, the value of the y-intercept in coordinate to any point with 0 gradient for c equal to 1 and 2. What? How are we supposed to know that? With nothing? Are we supposed to graph this to know? Because we're not even supposed to differentiate it to find the point with 0 gradient. Well, I guess we'll cheat with the calculator. I mean, the y-intercept is obviously still 2 because y-intercept is the n number. So looking at the trend, so I feel like when it's 1 is probably this is 2, the graph would what look like this. When c is 1, and when it's 2, the dip would be even bigger or something. That would be my guess. I'm guessing they just want you to graph it on your GDC. So we have x to the power of 3 minus 3c, so minus 3 x, if c is 1, right, plus d is 2 now. Okay, plot it. Okay, turn out that's why we can find the coordinate of any point with 0 gradient, because basically the maximum and minimum, which there were none when c was -1 and c being 0, but now c being 1, there seems to be a minimum when x is 1 and a maximum when x is -1. Doing the y coordinate. Yeah, it says coordinates, so we need both x and y. Seems to me it's 4. But let's just do it for, yeah, it's 4, so this is 2, 4, 0. Okay, that's c being 1. So I guess c being 2 would be even wider. How do I graph the other thing? Like this. So we'll change this to 6, right? If c is 2, you have -6. Yeah, go even lower. Right. So my guess was basically correct. It's difficult for me to predict how high or low the maximum and minimum are. So the maximum this time is negative 1.414. That's probably negative √2, and the value is 7. So it's like here with negative 1.414, 7.657, while the minimum is negative 1.414, positive 1.414, negative 3.657. The y-intercept is obviously still 2. Do I need to give x-intercept? Probably not. Give an expression of the derivative. So that's 3x squared minus 3c. And so otherwise, find the set of value of c such that you'll have a point of inflection with zero gradient. So point of inflection is for second derivative being zero. Zero gradient means first derivative is zero. So we need both of them to be the same point, right? So if the first derivative is zero, this is the first derivative. So we have 3x squared minus 3c equal to 0. Then we have x squared equal to c. So x is plus or minus square root c. And for the second derivative, we differentiate that again. So the second derivative is 6x. So turn out the point of inflection always occur at 0. So if you need the point of inflection to have a 0 gradient, you will need this to be 0. Then that will mean c is 0. Okay, so for ci, the only way the point of inflection also have 0 gradient is when c is 0. That's basically this case. You can see this is a horizontal point of inflection. Don't think we need to calculate that anymore. A local maximum and a local minimum. That's basically when the derivative is two different points. So whenever c is bigger than 0, there will be one maximum, one minimum. And then there's no point where the gradient is 0. Well, that's when x squared equal to c have no solution. That's when c is a negative number, right? That's why this graph have no maximum, no minimum, not even horizontal point of inflection. But these, when c is positive, obviously have one maximum and one minimum. So now, given that y of f have one maximum, one minimum, show that the y coordinate of the local maximum is blah. Okay, so that's when c is bigger than 0. And recall that the second derivative, if c is bigger than 0, the maximum and minimum is when x is positive and negative root c. But the second derivative is 6x. Right, so if you plug in a positive number, the second derivative would simply be positive, and so that would give you a minimum. Right, so a maximum have to be when x is negative root c, where c is bigger than 0. So to find the y coordinate, we simply substitute this x value into the function. What's the function? X cubed minus 3cx. So the function is x cubed minus 3cx plus 2. And so the x is negative root c. Just plug it in. So this is what? This is negative c to the power of 3 over 2 plus 3c to the power of 3 over 2 plus 2, so it's 2c 3 over 2 plus 2. That's what they want. Minimum, similar. So minimum when x is negative root c, so you allow positive root c, because that's when the second derivative is positive. So if you put it in, let's see, so this is what, 3 over 2 minus 3c 3 over 2 plus 2, so it's negative 2c 3 over 2 plus 2. Okay. Okay. And the question is, for what c, f would only have one x-intercept? sort of almost like finding the discriminant for a cubic. But okay, it won't be that hard. I mean, it will be quite difficult to actually find the discriminant of a cubic equation. Obviously, we don't even... I mean, there is a cubic formula, but we don't teach you that in IB, so it's probably quite difficult to use a similar idea to discriminant. So we'll probably just use the y coordinate of these maximum minimum. So when c is bigger than 0, we know the graph looks something like this. And you can see that the left-hand side of the graph would always go down to infinity. So there is always one x-intercept here. All right. So there's always one, exactly one. So basically, that's when you don't have the other side. All right. So you can see if the y coordinate of the minimum point is above the x-axis, so imagine it goes something like this, where this is 2, but the minimum doesn't. But the minimum is above the x-axis, you would have exactly one x-intercept. Alright, so that should be the way to do it. So we have exactly one when the y coordinate of the minimum point, which is this, is bigger than 0. Alright, then you subtract the 2 to be -2 and then divide by the -2, so you have to flip the sign. So we have c to a power is less than 1. Well, that makes c being less than 1. Okay. To have exactly 2, you basically have to have exactly this case. So you have one x-intercept and another here. Well, that's when c is 1. So that should be obvious. C is 1. Alright. But if you want to calculate that, it comes from the y coordinate of the minimum point being exactly 0. And then you have 3 x-intercepts. That's this case, 1, 2, 3. So you want the y-intercept, you want the y coordinate of the minimum point to be less than 0. That should give the opposite of this, so that's when c is bigger than 1. Okay. Okay, then we have a general one. Now d is just d. We have to basically repeat everything for ei. We need to find the condition that it has exactly one x-intercept. Okay, I think the first easiest thing to do would be considering, so case 1, you consider that d is positive, right? Then similar to what we have here, we have a y-intercept that is above 0, right? So the y-intercept is at d. And then the key is, notice that d doesn't affect the derivative, right? So the first derivative would still be this. What that means is the answer to c would simply be the same, right? When c is 0, you would have a horizontal point of inflection. When c is less than 0, you would not have any horizontal point of inflection or maximum minimum. Alright, so if d is bigger than 0, and if c is also less than 0, less than 0, you will have something that looks like this, because there's no maximum minimum. Then you obviously have only one x-intercept, so that would be one of the conditions. If c equal to 0, the graph would have a horizontal point of inflection like this. Then again, only one x-intercept, so that will also work. But for c to be bigger than 0, then you need Then you will similarly have a maximum and minimum. And similarly, you need the y coordinate of the minimum point to be positive. But since the derivative is the same, the x coordinate of the minimum is the same. It's still just root c. It's just that the y coordinate of minimum would now be negative 2c derivative plus d instead of 2, because remember this 2 come from the fact that d was 2. So now if d is just d, we'll need this to be bigger than 0 to have exactly one x-intercept. So we need this to be bigger than negative d, so we cancel out, we flip the sign, and we divide the 2 away, the negative 2 away. Then we just square the other side and cube root that, so it's d squared over 4 cube root. Okay. So this case, so this happened under the assumption that c is bigger than 0. Alright, so when c is between 0 to this, you only have one x-intercept. But remember, when c is negative and when c is 0, you also would only have one x-intercept. So if d is bigger than 0, then you basically only need c to be less than that. Because if c is negative, you would get only one x-intercept no matter what for c. Okay, what if, case 2, what if d is 0 though? If d is exactly 0, then the picture becomes, you have a y-intercept there. Then if c is less than 0, remember it would have no maximum, no minimum, then there's only one x-intercept, so that's fine. If c is 0, remember the picture will look like a horizontal point of inflection, so that's also fine. But if c is bigger than 0, there would be a maximum and minimum, so the graph would have to look like this. Then you have no way of having only one x-intercept, because once you have a maximum and minimum, you will have the other two x-intercept, right? So that just doesn't happen. So if d equal to 0, c will have to be less than or equal to 0. And lastly, what if d is less than 0? So if d is less than 0, then the graph becomes this. Alright, so when c is less than 0, then you still only have one x-intercept. If c equal to 0, you'll have that horizontal point of inflection case, so still 0. Now this time when c is bigger than 0, alright, we'll be expecting, this is d, no, that's not the correct graph. You'll be expecting that there is a minimum, there's a maximum, like this. And so this time we need the y coordinate of the maximum to be less than 0. Alright, so that it doesn't create any more new x-intercept. So we'll need the y coordinate of the maximum, which is this. We need 2c plus d to be less than 0 in order for the maximum point to be below the x-axis. So we have what? Negative d. Then we don't flip the sign. Then we square that and take the cube root. So you need c to be less than d squared over 4 cube root. Okay. Oh, it's actually the same condition as before. Alright, so when c is bigger than 0, you need this, but when c is less than 0 equal to 0 is fine anyway. Okay, so therefore if d itself is less than 0, c also need to be less than this. Okay, so the condition for d being less than 0 and bigger than 0 is actually the same. So the conclusion is if d is 0, you need c to be less than or equal to 0. C to be less than or equal to 0. But if d is not 0, so if it's positive or negative, you simply need c to be less than the cube root of d squared over 4. Okay? I think that's all the condition. All right. Yeah. Hopefully, probably. All right. I've just checked the answer. Turn out the solution do it slightly different than me. Instead of considering the cases for D, they consider cases for C. So they consider what happened if C is less than or equal to 0. As you can see, if C is less than or equal to 0, it basically always works. So no matter what D is, if C is less than or equal to 0, then there's always only one x-intercept. But then consider if C is bigger than 0, then they think, okay, what if D is positive, what if D is negative, so on and so forth. And so the answer is basically this, but they make D the subject. Alright, because they start by considering that C is now positive, so they want to find D in terms of C. So you get what? You said C cube less than D squared over 4, so times 4C. And like square root that. Alright, so D will have to be bigger than the square root of 4C cubed, or D will have to be less than the negative of root 4C cubed. So then just from this, they separated into the case where D is negative or D is positive. Alright, so logically, my answer is the same as the one solution give. Or if you have this condition, alright, when C is bigger than 0, but if C is less than or equal to 0, then D could be anything. There will still be only x1. Then there will only be one x-intercept. This is also correct. Logically, these two conditions are exactly the same. The marking scheme do not specify how do you mark it if you give the condition like this. So I'm guessing it'll be up to the marker to hopefully realize that they are logically the same. I mean, it's a bit unfortunate they didn't give both solution, because I don't think they mentioned whether we should make C the subject or D the subject in the question. So yeah, it is what it is. This would still be my solution. I would have no way of knowing that they want the other way if I did not read the solution. Alright, we'll go on with the original video. So the question is, some polygons, numerical value of the area is same as the numerical value of the perimeter. For example, a 3x6 rectangle have an area of 18 and perimeter. Oh, okay. For each polygon in this question, let the value of the area be A and value of the perimeter is B. Find the side length S of a square so that the area will equal to the perimeter. Well, okay, the area is S squared, the perimeter is 4S, so S is 4. And now we have a n-sided regular polygon is cut into end. Congruent means the same. Same isosceles triangle. Let x be the length of each of the triangle. Y be the third side, so that's also the length of the side of the regular polygon, I think. Then the angle, obviously 2 pi divided by n, blah blah blah. Write down the area of one of the isosceles triangles is half AB sine C, so half x squared sine the angle. And then they want y. So they sine half of the angle, so that's the hint to cut this in half. Alright, so we have y over 2 being sine the angle. You cut the angle in half. Wait, no, sine is opposite over hypotenuse, so it's like this. Y over 2 over x being sine the angle. You make y the subject, so y is 2x sine pi over n. Okay. Consider the n side of the polygon such that a, you go to p. So the area of the whole thing would be n of this. So it'll be n over 2x squared sine 2 pi over n. The perimeter would be n of this, would be n of y, because y is the side length. So it's 2n x sine pi over 2. So I think we will have to find x, right? So we cancel one of the x, we cancel the n. So we have x times 2, x times sine 2 pi over n. You multiply this 2 to the right, 4 sine that. Then obviously we'll use double angle formula, so it's 2 sine a cosine a. Then the sine cancel out, the 2 cancel out. So x would be 2 over cosine. Then they want to find what's actually a and p. Well, so what we do is we'll put this back here, right? So it's 2n x sine. So that's 2 times 2 is 4, and sine over cosine is tangent. Okay, so that's why the a and the p would equal to this. Okay, I don't know what that's supposed to mean. Oh, they are gonna take the limit of that. Okay, they give the Maclaurin series of tangents, and then they want to find the limit. Okay, that seems like we need to do some serious math. So 4n, so the Maclaurin of 10 is, so you put this to be x, so it's pi over n plus pi over n cubed over 3 plus 2 pi over n to the power 5 over 15. Then we will expand the 4n, so we have 4 pi plus, what's the next term? 4 pi cubed over 3n squared, and then we have 8 pi to the power 5 over 15n to the power 4, so on and so forth. But the key is when n go to infinity, any term that has n in the denominator will become 0. Alright, so this limit would simply be 4 pi, because the rest becomes 0. And then it says interpret what you have done in here. Well, when n go to infinity, you're basically cutting this polygon into infinitely many parts. So the limit is basically a circle. So a circle of equal, like numerical value of A and P equal A and P would have an area, would have an area and perimeter of 4 pi. Alright, so basically a circle. Okay. And then what? We have right angle triangle. So it's probably this is A, this is B, and by Pythagoras we have that. So that A is equal to P. So the area is A times B over 2. The perimeter is A plus B plus the square root thing. We need to make A the subject. So we probably need the square root to go away. The only way for that to happen would be you move everything to the left. Minus A minus B. Then like you square both sides. So before that, the left is AB minus 2A minus 2B. Then you square both sides. A squared plus B squared. 4. Well, what's the square of the top? I didn't memorize A plus B plus C squared. So we have AB times AB, so that A squared B squared, and then minus 2A squared B minus 2AB squared. The next one, we would need more space, do we? Minus 2A squared B. The next one plus 4A squared plus 4AB. Then next one minus 2AB squared plus 4AB plus 4B squared. Well, then we multiply the 4 to the right, so it's 4A squared plus 4B squared. What do we have on top? We have A squared B squared. Then we have minus 2 A squared B squared minus 2 A squared B squared. So it minus 4 A squared B. Oh, I mean A squared B. What else? Minus 2 AB squared minus 2 AB squared minus 4 AB squared. We have plus 4AB plus 4AB, so plus 8AB. And then we have plus 4A squared plus B plus 4B squared. So those cancel out. And then I think we can factor out AB. So AB, then we have AB minus 4A minus 4B plus 8. Alright, so two things multiplied together to be 0. So either this is 0 or that's 0, but AB cannot be 0, they're the lengths. So we have this equal to 0. Should we take out A? Probably. So we factor A out here, B minus 4. That doesn't work. B minus 4. They have 8 though. Plus 4. Four B minus 8. I got this though. What they have there is B over 8 over B minus 4 plus 4. Okay, so seems like they have make this minus 16. But if minus 8 become minus 16, you need to add 8. Then you separate it. So you separate the denominator. You have 4 b minus 4 over b minus 4 plus 8 over b minus 4. So this cancel out. Therefore becomes 8 over b minus 4 plus 4. So I guess they do this for a reason, right? Otherwise it's kind of odd. Then use the result of f. Determine the 3 side lengths of the only 2 right angle triangle for which a, b, and capital A, capital P are all integers. Wow. That looks hard. Okay, so how do we start? We need a to be an integer, but a is this, where there is a fraction there. So we need that fractional part to be an integer. Right? How can that to be an integer? Can only be maybe a over 1 is a over 2, a over 4, or a over 8. Otherwise, it won't be an integer. But b cannot be negative, right? B is a length. B cannot be negative. So the only choice is 8 over 8. So that's b being 4. So for a to be an integer, b have to be 8, or, oh no, I'm wrong, or 6, because 6 minus 4 is 2, or 5, because 5 minus 4 is 1. Alright, if b is 8, then a, okay, if b is 8, you put it in, then it's a over 4, 2 plus 4 is 6. If it's 6, then you get a over 2, so 4 plus 4 is 8, or 5. Put it in a over 1, so 12. But the question says a have to be bigger than b, so this doesn't count. But since a is bigger than b, therefore it's either a is 8, b is 6, or a is 12, b is 5. Okay, but we need a and p to be integers as well, so we just have to calculate what would that be if a equal to 8, b equal to 6, then the area is a b over 2. It's 8 times 6 over 2, so that's 24. Okay, that works. If a is 12, b is 5, that was a being 12 times 5 over 2, so that's 30. Okay, that's also work. So that's the 2 choice. Alright, the 2 right angle triangle. Determine the area and perimeter. Oh, I did that as well. 24, 30. Okay, G is a bit tricky. For IB is kind of rare for this kind of analysis, where you have to think like a have to be an integer, so this have to be divisible. But if you figure that you should do that, then it's quite easy. There's not that many choice. Then the rest is straightforward. Is that the end? Okay, I think question 2 is slightly easier than question 1. This C analysis, especially F, where you suddenly have to do everything by yourself, although you just repeat the same process, but that was hard. So yeah, this would be my solution of this paper 3.